Introduction to Statistical Learning, Chapter 8. And we're in the conceptual questions, question 2. Okay, so this is the question right here. So it's mentioned in section 8.2.3 that boosting with one depth or depth 1 trees or stumps leads to an additive model. That is a model of the form here, where f of x is the sum of all of these mini functions over x. Okay, so now we're meant to explain why boosting gets us a model of this form. Okay, and it gives us a hint to start with algorithm 8.2, and this is, I've just reproduced algorithm 8.2 right here. Okay, so I'm not really sure what is expected of this question. I doubt that it wants like a rigorous proof, and I don't know that I could put one together on the fly, but so I'm just going to answer with pictures and intuition here. Okay, so let's just think about what is happening with this algorithm here and what the net result is. Okay, so so all this algorithm is doing is it's starting this off somewhere, okay, and I'm representing that somewhere with this blue dot. Okay, now what we're working in here is actually function space, but I've just plotted it as Cartesian space, right? But we actually want to think about this as a bunch of functions in here. So if you're a little bit well versed in some of these ideas, then this is overly simplified, but it's okay, right? So we have this function space, and we're trying to arrive at at a destination function. Okay, but that destination function is just represented as a point here. So, but let's just see what happens with this algorithm. Okay, so first we fit a weak learning algorithm to that, and we're going to call it f hat 1. Okay, and f hat 1, so it's a weak learner because it's maybe it's only using one variable of the possible variables, right? So there's more information that it could use, but it's only using a subset of that, and so its predictions aren't going to be that good. And so if we just used f hat 1 as our estimate of our ultimate function up here, well, it's going to cast us far afield. Okay, it's going to cast us roughly in a kind of okay direction, but way far away from where we want to be, and we know that. And so we only step along that path length lambda, right? And we can set lambda to whatever, to a constant value. Okay, so we go along lambda, and now we're at this new point, and now we're going to fit another function. Again, another weak learner, okay? And that weak learner is going to cast us in a different direction for a couple of reasons. One is because we're using perhaps a different, a different feature set, right? A different subset of the x's, okay? But secondly, we're at a different starting point, right? We're no longer starting at the blue dot. We're starting at where f1 hat lambda took us. And then we repeat that process, right? So again, f2 hat is going to cast us in some direction, okay? But we're going to step along at lambda, and then that lands us somewhere, and then we fit another function, and so on and so forth. And we kind of snake our way up to the ultimate function here. So all that we've done during all of this is exactly what's portrayed right here, right? We have taken the sum of lambda weighted f hat values, where each f hat to the b is some weak learner. Okay, I guess maybe it doesn't even have to be a weak learner, but just some learner that we maybe don't have complete trust in, or something like that. So I guess that's my answer here. If you have better answers, or you think that the question is asking for something a little bit more rigorous and what that might be, then let me know. Okay, I'll call it good.